So let's build this Turing machine. And what that essentially amounts to is, I'm going to tell you, we're going to develop the instruction set, the instructions that this machine should follow. And what are these instructions? They're basically telling the machine what to do depending on its current state and what it reads on the tape. Okay. So what would an instruction look like? So let me remind you what an instruction looked like for the DFA, and we use the graphical representation. Okay, so an instruction for a DFA looks something like this. Okay. You're at some state Q, let's call it Q1, for example, and if you read the bit 1, okay, then transition to the state Q3. That was an example of a DFA instruction. Okay, we used graphs to represent this. Okay, well, in the Turing machine, so what else is going on? Okay, so not only do you read a bit, okay, and you're in a current state and you're going to transition to a new state, but when that happens, you might also write a bit to that position. Okay, and then you also might move left or right or stay still. Okay, so we can call that move left, right, or stay still, which means just do nothing. Okay, so a Turing machine instruction is augmented. Okay, so it's augmented not just so we don't just tell you what state to transition to depending on what bit you read. Okay, so let's say you read a 0. Okay, we also tell you what bit you should write. Okay, and we also tell you whether or not you should move. So for example, we might give a move right instruction. So now let me tell you exactly what that means. Okay. This means if in state Q1 and you read at your current memory location 0, okay, you read 0, okay, then here's what you do. You write 1, so this is what you do. Write 1, okay, move 1 step to the right, move right, okay, and transition to state Q3. Transition to state Q3. Okay. So let me illustrate that, let me illustrate that instruction pictorially in a situation like this. So imagine that I have a Turing machine with 4 states. Okay, so I have a Turing machine with states Q0, Q1, Q2, Q3. And it's got its read-write head, and it's at some position in the tape, let's say, and it's currently reading 0. And let's say there's 1 here, and this is star. Let's say there's another 1 here, and let's say a blank. Okay, so this is the situation. So, and you're in state 1. So the Turing machine examines its state. It's in state Q1. It's reading a 0. So it looks, I'm in state Q1 and I've read a 0. So this is the relevant instruction. Okay. So what is it telling me to do? It's telling me to write 1, okay, move 1 step right, and transition state to state Q3. So let's see what that would look like. So what's the situation after executing that instruction? So after executing that instruction, we've got our star. Okay. We've got our 3 slots, and let's say our blank. Okay. Now you've moved right 1. Okay. So you've moved right 1, and you've written 1 to this location. So this 0 becomes a 1. Okay. Then you have 1, 1, and you have moved to the right. Okay. And you have transitioned states. So you have Q0, Q1, Q2, Q3. Okay. So you are now in state Q3. So let me go over that again. You were in state Q1. You read in 0. Okay. You were in state Q1. You read in 0. That says that this is the relevant instruction. Because you're in state Q1, you read in 0. What is it telling you to do? Write 1. So write a 1 here. That's that 1. You can put it in red if you want. So we wrote that 1. Okay. Move to the right. So you've moved 1 step to the right. Okay, so now instead of being at this position, you're at that position. And transition to state Q3. So you've transitioned to state Q3. Okay. So that's an example of a Turing machine instruction. And this is how we would represent it. So depending on what state you're in, and depending on what you read, okay, you will write something to that location. You may not write anything, so that's a perfectly valid instruction. Don't write anything. Okay. You move left or right, or you may not move at all. That's also perfectly valid. And you change states. or you may not change states at all, in which case the arrow would be to itself. Okay, so that's an example of a Turing machine instruction. We're going to keep that on the board and erase this guy. Okay. We'll now use those kinds of instructions to build this machine. We're now going to build our Turing machine, okay, to mimic this algorithmic pseudocode. So we're going to have 5 modules. So what we'll do is we'll build each of the modules and connect up the modules. Okay. So let me draw a line here. And let's start with the first module, which says check the input format. Okay. So we're going to start in some state. Let's call it step 1. Why not? We're in step 1. So we'll start in step 1. Okay, we'll start in step 1. Okay, so step 1. So I'm just choosing the name step 1 for my state. That's perfectly fine. Okay, we will call this the start state. So remember there's an arrow coming in here. Okay, and now check the input format. So keep moving right, okay, as long as you don't see a pound. Okay, because we want to check that there's exactly 1 pound. So, you know, as long as you're in step 1 and you have not read in a pound, so you've read in star, 0, or 1. If you've read in a blank, if you've read in the blank, the input is not of the right format, because even the empty should have a pound. Okay. So, as long as you keep reading in star, 0, or 1, star, so I'll write this as long as you read in star, 0, or 1, don't write anything to the tape, just move right. So this is actually 3 instructions, but I don't want to write all of those 3 instructions. Technically, this is 3 instructions. 1 instruction for, one instruction for if you read star, don't write anything, move right. If you read 0, don't write anything, move right, and stay in this state. If you read 1, don't write anything, okay, move right and stay in this state. Okay. Now, what else might you read? You might read pound, so you might read pound. In which case, if you read pound, okay, that means you're going to change states, okay, and sort of remember the fact that you've seen a pound, okay, and let's call that state that you go to, let's call it Q1, okay, and you don't need to write anything. Okay. And you can move right. Okay, so if you read in pound, you don't need to write anything, but you can move right, which means you're ready to process the next bit. Okay. So you can either read in star, 0, 1, or pound. There's one other thing you can read in, which is a blank. So you could read in a blank. Okay, so there's another thing you could read in, which is you could read in the blank. If you read in a blank and you haven't read pound, it means there's no pound. This means that you can immediately stop and reject. So we'll call this an error state. You can stop and reject. So you read in a pound, doesn't matter what else you do. You don't need to write anything, you don't need to move. Okay, you just stop and you're in an error state. So what this means is that you stop and reject. You say no, stop. Okay, so important observation. Okay. In a Turing machine, there are these states which we call halting states. So states where the computation stops and you deliver your verdict, yes or no. Now, such states did not exist in the DFA. In the DFA, they were just reject and accept states. They were the yes states and the no states. And the reason for that is that the DFA computation has to end when the input ends. And then you just look at your current state and say, am I in a yes state or a no state? The problem with the Turing machine is that there's no well-defined ending to the computation because this guy can move around as much as it wants. Okay. So it's moving around as much as it wants. And at some point, it enters into a halting state. So it stops. And so just like there are yes states in the DFA and no states in the DFA, okay, in the Turing machine, there are halting states. Some of them are yes halting states, and some of them are no halting states. And in the other states, the computation just continues. Okay? And it's not determined by the length of the input. Okay, so So we've got a halting state here. All right. And what happens if you see a blank, you halt. If you see a pound, you go into this new state where what are you doing in this new state? In this new state, okay, you are checking to make sure that you don't get another pound because you want exactly 1 pound. Okay. So from this new state, now that you've moved right, if you see another pound, again, you reject. Okay, so we will reject if you see another pound from this state, and it doesn't matter what you do, you don't have to write, you don't have to move, because once you reject, you reject. Okay, the computation stops. On the other hand, okay, you might be reading zeros or ones, okay, not a pound. So as long as you read zeros or ones, no problem. If you read 0 or 1, no problem. You don't need to write anything, just move right. Okay, so you'll read zeros, ones, and so on. You keep moving right. And at some point you come to a blank. And when you come to a blank, that means that you've hit the end of the input string and you only saw 1 pound. So if you come to a blank, okay, you come to the blank, you don't write anything. You don't even need to move anymore. Okay. And we will say that, you have gotten, you have checked the input string. Okay. You have checked the input string for 1 pound, and you're ready to start step 2. So transition into the state that corresponds to step 2. Okay. And what have we done here? We have just implemented this module, the module which is check the input format. Okay. So just to summarize what's going on here, you're in step 1, checking the input format, where you start. You keep moving right as long as you see either star, 0, or 1. At the beginning you see star, then you see zeros and ones. If you come to a blank, you reject. If you come to the pound, you move to a new state. Okay. And in this new state, you're checking to make sure that there are no more pounds. So if there's another pound, you reject. As long as there's no more pounds, you stay here. You get to a blank, you verified no more pound, you're ready to move into step 2. Voila! Beautiful. Okay. So now let's see what happens in step 2. You're just going back to star. Okay. So step 2 is actually really easy. In step 2, you just move left, okay, until you hit star. So, as long as you read anything but star. Okay, so as long as you see anything but star, so you see either 0, 1, blank, or pound, okay, you don't need to write anything. You just move left. Okay, you just move left. The only thing that needs to alert you is if you come to star, it means that you've gone back to star. You don't need to move, you don't need to write, you just, you stop. Okay, so if you come to star, you don't need to write, you don't need to move, okay? You just stop, okay? So you've come to star, and now you're ready to do step 3. So you move to the state that corresponds to step 3. Let's call this step 3. Okay. And voila! We've implemented module 1 and module 2. Okay. So now let me tell you how to implement module 3, step 3. Okay, so what are we doing in step 3? In step 3, we're moving right, okay, as long as we see a marked bit, or, as long as we see a marked bit, we keep moving right. Okay, when we get to an unmarked bit, an unchecked bit, okay, that's when we need to do something. Okay. So we're currently at base, and we are reading star. So if we see star or a marked bit, we keep moving right. So in step 3, okay, if we see star or the mark, okay, if we see a marked bit, okay, then, we don't need to write anything. You just move right. Okay. If we come to pound, we need to go to step 5. Okay. And we'll deal with that later. So if we come to pound, okay, so let's say we come to pound. If we come to pound, if we read in a pound, that means there are no more bits in the left. So if we come to pound, come to pound, okay, we can move right, but we don't need to do anything. We don't need to do anything. We can move right, okay, and we are currently in step 5. Okay, so that state is step 5. We've been told if you come to pound, go to step 5. We'll deal with step 5 later. Okay, so the only other thing that can happen is it's not star, it's not the check, it's not pound. So that means you come to an unchecked bit. Okay? And there are 2 situations there. You can either come to a 0 or a 1. And remember, the goal here is that if you come to a bit that's unchecked, you have to remember it. So you have to do different things. You have to move to different states, whether it's 0 or 1. Okay, so here we're going to move to one state if it's a 0. Okay, so if you see a 0, then you don't need to. What do you need to do? What you need to do is you need to mark it. So if you get to a bit, okay, that's unchecked, check it. So you have to mark it with a check. Okay, so mark it with a check. I'll write that as check it. Okay, and okay, now you can move right. Okay, you can move right. And you are basically now moving to a state where you're looking for a 0. Okay, you are looking for a 0. So let me call this the state Z for 0, okay, in step 3. Sorry, you're going to go to step 4 and you're looking for a 0. So let me call it Z for 0, step 4. On the other hand, if you find a 1, you're going to mark it, okay, and you can move right if you want. Okay. And now you are looking for a 1 in step 4. So I'll call this the 1 in step 4 state. Okay, nice. Okay. And that's it. We've implemented step 3. Okay, that is step 3. Okay, step 3 is just doing that. Move right until you get to your first unchecked bit. Okay. If you come to pound, step 5. Otherwise, mark your bit, move right, and get ready to search for the match. Okay. So you are now searching for the match, which is a 0. Okay. So you're going to move right. You're going to keep moving right as long as you don't see pound. Okay. As long as you don't see pound. Okay. So as long as you see bits, 0 or 1. So they'll have to be unchecked. Okay, you don't need to write anything. You keep moving right. Okay. What's the alternative? You come to pound. Okay, so if you come to pound, now you're getting ready to see if you match. Okay, so you don't need to write anything. You can move right. So now you've gone past the pound, so you're in the second string. Now you're going to have to move right, and you're still searching for the 0. Okay. So actually, let me call this state Z3. Okay. And let me call this state Z4. So I've come to the pound. Now I keep moving right. I keep moving right as long as what I see is checked. I keep moving right as long as what I see has been checked. Okay. If on the other hand I come to blank, okay, or I come to 1 because I'm looking for 0, I can reject. So if I come to blank or 1, I don't need to do anything. I don't need to move. I can reject. I can stop and reject. Error. Stop and error. Okay. So let's see what's going on here. In step 3, I moved right and I found an unmarked 0. I marked it and I moved into state Z3. Okay. In state Z3, I'm moving right until I get to pound. Okay. When I get to pound, okay, I move to state Z4. In Z4, I'm moving right as long as the bits I see are marked, because those have already been matched. Okay. So the only thing that can happen other than seeing marked bits is I come to blank, 1, or 0. If I come to 0, it means I've matched my 0. If I come to blank or 1, if I come to 1, it's not matched. If I come to blank, there are not enough bits, so I reject. If I come to 0, I have matched. If I come to 0, okay, I mark it, and I don't need to move. And then what does the algorithm say? If you match the bit, verify the match, then you go back to star. But going back to star is just step 2. So I go to the state which corresponds to step 2. That's actually this state. So one way in which I can sort of illustrate that, it's hard to kind of draw this arrow all the way there, so I'll just illustrate that this state and this state are the same state. They're both step 2. And I continue in step 2. Okay, I continue from step 2. Step 2 gets me back to star, and then I repeat step 3 and step 4. Similar situation from 03. So I'm looking for a 1 after the pound. So I first need to find my pound. So as long as I see 0, 1, okay, I move right. Okay. So I'm looking for 1 past the pound. So as long as I see unmarked bits, I move right. The moment I come to a pound, which I have to come to, now I don't do anything, I just move right. Okay. And I enter the state where I'm looking for my 1 in step 4, after the pound. So I'm looking for my 1 in step 4. If I come to blank or 0 from this state, then I can error. If I come to 0, it doesn't match the 1. If I come to blank, I don't have enough bits. Okay. So same state. If I come to blank or 0, I don't need to do anything. I just stop and reject. On the other hand, if I come to a 1, I mark it, and I don't need to move. I just go back to step 2, which takes me back to star. And there, I've implemented step 3 and step 4 now. So step 3 took me to one of these states, which is the starting point of step 4. If you wanted, I could maybe do something like a dotted thing here. Label this step 4. Okay? So I've now implemented 1, 2, 3, and 4. Wow! That's what a Turing machine looks like. Except we haven't implemented step 5. What's happening in step 5? Okay, in step 5, I ran out of bits in my left string. I came to pound, so I need to check that there are no more bits in my right string. So I'll keep moving right as long as I see a mark. I keep moving right and staying in this state as long as I see a mark. Okay. I don't need to write anything, I just keep moving right. If I come to something that's not marked with a check, it's either going to be 0, 1, that means there are too many bits on the right string, or blank. Okay. If I come to 0 or 1, I have too many bits on the right string, so I don't need to do anything, I just halt and reject. The only case where I accept is if I come to blank. In which case, I don't need to do anything else. I halt, but now I don't reject. I say, yes, I've completed the entire matching process and even come to this final blank. Okay. So this is an accept state. Okay. So you see, and I'll quickly summarize this Turing machine again. We'll just go through the inner workings. Okay, you'll have to sit down and go through this yourself. In fact, the best thing to do is actually construct it yourself. Okay, but what you'll see is that this Turing machine has regular states and then halting states. It has got an error state and an accept state. These are the halting states. So these are called halting states. So you see why we don't want to be drawing Turing machines, any more than we have to. It's just like we don't want to be programming in machine code. Okay? We'd much rather program in C++ or Python. Okay? And that's what this is getting at. So this is sort of a high-level code. This is the actual executable instruction-based Turing machine. Okay, now let's go through it quickly. Start step 1. Okay, you move right, checking for 1 pound. Okay, if you find 1 pound and only 1 pound, you enter step 2. In step 2, okay, you have to move left until you hit star, at which point you stop and enter step 3. In step 3, you move right as long as you see marked symbols or the star, which is where you were. If you come to a non-marked symbol, it's either 0 or 1. Okay, in which case you transition to the appropriate state and search. Okay, so you then you go up to the pound and continue until you find another 0, in which case you go back to star. Or if you found a 1, you go up to the pound and then continue until you find the next unmarked bit, which is a 1, and you go to step 2, which returns you back to star. Okay, so that's what's going on here. Anything else, and it's an error. Okay. The only other thing that remains in step 3 is when you were moving right, okay, you didn't find an unmarked bit, 0 or 1, you came to pound. In which case, you continue moving right as long as you see marked bits. Okay. If you come to the end of the string and you never found an unmarked bit, that means that both strings match and you accept. Otherwise, you reject. That's the Turing machine. Now, we're not going to draw any more Turing machines, and you'll only have to do it once, I think, in the assignment. Okay, so we're going to focus on high-level machines, and let's do a few more examples of this kind of high-level code to show you some of the power of Turing machines. Okay, so let me erase.